In Chapter 5, we will be looking at quadratic functions. Quadratic functions are something that you did cover a little bit in Algebra 1. We are going to be going quite a bit more in depth than that in Algebra 2. We saw a bit yesterday in our graphing calculator exploration. I guess that's today. And that's kind of what we're going to look at today. We're going to look at using transformations to graph quadratic functions in this section. So, things that you should already know about quadratic functions. You should know that the equation is going to look like something like y equals x squared, or perhaps something more difficult, like y equals 3x squared minus 2x plus 5. You should also know that the graph of a quadratic is going to be this curvy shape that we call a parabola. Something else you should know about quadratic equations is how to factor them. That's something you dealt with a bit in Algebra 1. We will be looking at it again in Algebra 2. However, we won't get there until a little bit later on in the chapter. But if you're thinking, wow, I don't remember how to factor, you might want to start looking at that. So we're going to graph quadratic functions in a couple methods. The first method is we are going to make a table. Making a table is a fantastic method of graphing something that you don't know what it looks like. So, to make a table here, we're going to start with an equation, y equals x squared. It's a basic parent function for a quadratic. We're going to get our table here. A lot of times, you're going to need to use vastly different numbers to graph a quadratic. However, this section, if we use -2, -1, 0, 1, and 2, you will be fine. Later on in the chapter, we will talk about how to figure out what numbers you need to use for the x value. So we need to plug some numbers in. Let's start down the bottom with x equals 2, because those are actually easier to plug in. We know that 2 squared equals 4. And so we get y equals 4, put it in the table. Plug in 1 squared, hey, that equals 1, plug it in the table. 0 squared, oh, look at that, 0, plug it into the table. Now these next two are a little bit more difficult. And you might be thinking, well, oh no, I know how to take the square of these, that's easy. Yes, but people mess up because they forget to put it in parentheses. -1 squared is 1. I get people every year that say, oh no, but my calculator says -1 squared is -1. That's because it's taking 1 squared and getting 1, and then it's slapping it with the negative. The same thing when we plug in -2. We get -2 squared is 4, so we put that into the table. Now we need to graph it, so we get an appropriate sized graph, appropriate sized grid. We can start plotting our points, -2, 4, -1, 1, 0, 0, 1, 1, 2, 4, and then we can connect the dots in a parabolic fashion. What is a parabolic fashion? It needs to be curved down here at the bottom. You do need a curve, not sharp, pointy angles. I know that sometimes, like, not everybody's a great artist. I get that. You've seen me graph stuff, but make an effort to make it curved. So let's look at another one. One that's a little bit harder. Y equals 2x squared minus 4x minus 3. If you want to try this one out on your own, feel free to pause the recording right now. Try and graph it. See if you can do it. And then just push play when you're done. But we will we'll have one that you can try on your own right after this as well. So we're going to do the same thing. We're going to plug it into the table. Put it in there. Plug in our values for x. And we can just start at the top this time. Y equals 2 times -2 squared minus 4 times -2 minus 3. -2 squared is going to be 4. 4 times -2 is -8. And so we get that. Then, 4 times 2 is 8. Minus -8 is plus 8 is 16. Minus 3 is 13. Go ahead and plug that into your table. And then we can do the same thing. -1, plug it in. We get y equals 3. Plug in 0. Yeah, that one's easy because these guys are both 0. You get -3. Goes into our table. Plug in 1. -5 plugs into the table, and plug in 2, and we get -3 again. Hey, look, we have some repetition of numbers here with the -3. That's a good thing because those quadratics are going to curve back up. So most of the time we are going to see some repeating numbers. It is possible that we won't, depending on where the vertex is, but a lot of times, especially today, there should be some repeats. So we can put this into a graph. This is a graph from last time, but this one's not going to be big enough to fit the numbers that we have. So we're going to want to use a different graph. Here, this graph should work. When graphing these, just like when you graph everything else, I recommend graph paper. It makes it much easier, quicker, neater, and more accurate. So we have our graph, we can plot our points and connect the dots. Here, notice the vertex is here. We only have one point to the right of it. That's okay. We can still get the shape. If you really want to, you can notice the symmetry here. Well, we should have another point right up here at 3, just 1 over, so at 3, 3. And then we can even go up 4, 13. So you can use symmetry to help you with this as well. So let's try one on your own, making a table. So try this equation, y equals x squared plus x minus 2. Make a table, find some points, graph it, pause your video, and then start it again when you're done. How'd you do? Do you think you got it? Well, let's check and see. So we have our table. We're going to plug in our value. You like that animation? I had a little bit of a learning curve while I was doing this. Get our x values. Start plugging them at the top. Y equals, or x equals -2. Plug it in. We get 4 minus 2 minus 2 is 0. Let's plug in 0. Plug in -1 to get -2. Put that in the table. Plug in 0 to get -2 again. Put that in the table. Hey, look at that. There's that repetition. We don't have the one in the middle. Means our vertex is probably going to be -1/2. We'll learn how to find the vertex later on. But we have the repetition. My guess is that 1 is going to be 0. So we can plug in 1. And look at that. 0. Notice the symmetry. Plug in 2 to get 4. It goes in there. We can graph it using an appropriate size graph. Going to go from -2 to 4. So here's a graph that'll work. We can plot our points. Notice the vertex is going to be down here somewhere. You don't have the point on the vertex. That's okay. You can still sketch the graph and make it look okay. So how'd you do? Did you get it? We have a second method for graphing quadratic functions, and that would be along the lines of what we did yesterday with the calculator lab. That would be using transformations. Using transformations with quadratics is like using them for lines and absolute value functions that we already looked at this year. In fact, absolute value functions and quadratics, as far as transformations go, are basically identical. The only difference is that when you graph a quadratic, you want to make it look like a parabola instead of a V. So let's use some transformations. First, we can start by looking at the parent function, y equals x squared. We graphed this one already, so yeah, there we go. We can look at a horizontal translation, x minus 2 squared. This is going to move 2 to the right, not the left. It's going to move 2 to the right. This minus is part of the equation. So it's going to move 2 to the right. So we can have our parent function, and then goes 2 to the right. And that's the graph of x minus 2 squared. We could do a vertical translation, x squared plus 3. Notice where the plus 3 is in relation to where the minus 2 is. Horizontal, we're inside of the squared. Vertical, we're outside of the squared. So graphing x squared plus 3, we start with the parent function, y equals x squared, and then we move it up 3 to get to the y equals x squared plus 3. Now, a lot of times we're not going to be looking at either horizontal or vertical translations. We're going to be looking at both at the same time. So here we have y equals x plus 1 squared plus 2. Which way do you think x plus 1 is going to move it? If you said to the left, that is correct. Because remember, the minus is part of the equation. This is x minus negative 1. So it's going to move it 1 to the left and up 2. So to graph it, we can start with our parent function, then move it 1 to the left, up 2 to put the vertex at negative 1, comma 2. Notice that none of these have changed the shape of our graph. They've just changed where it is. If we want to change the shape of it, we need to do a stretch or compression. And so, before that, try this one. Y equals x minus 2 squared minus 1. So see if you can graph y equals x minus 2 squared minus 1 using transformations. Think about where the vertex is going to be and graph it. Go ahead and pause, then push play again when you're done. Do you think you have it? Did you get your vertex at 2 comma negative 1? Start at the parent function. It moves right down there. Is this where your graph was? If yes, nice job. All right, now we can get on to changing the shape using a vertical stretch or compression. That's going to be with the number being multiplied to the outside of x squared. And so here we have 2x squared. Each of our y values is going to be multiplied by 2. So if we graph it, looks like this. Well, 0 times 2 is still 0. 1 times 2 is 2 instead of 1. This one's at 4. If we followed all the way up, it would be at 8. An easy way of checking to see what this stretch or compression should be if you're looking at the graph, when you go over 1, how far do you go up? That's going to be this number. So if our first point was at 1 comma 3, it would be a 3x squared. And this leads us into our general equation for quadratics with transformations. That's y equals a times x minus h squared plus k. H moves it h units to the right, k moves it k units up, a is a vertical stretch, and this puts the vertex at the point h comma k. And again, keep in mind this negative here is part of the equation. Everything we do to the x is backwards from what it seems like it should be. So this is graphing quadratics using transformations and making a table. You want to be prepared to do a quick group assignment, group project, group questions at the beginning of class. I'll see you then.